it's Claire Saunders from What's New in Electronics, and it's day 2 of IPC Apex 2026, and I've been joined by Kevin from Indium Corporation. How are you?
Doing great. Thanks for having me.
Absolute pleasure. It's nice to see you again.
Yeah.
So how's the show been going for you?
The show's been great. Good traffic. A lot of really exciting conversations. Get to hear a lot about what's new in electronics and seeing a lot of different trends in multiple different industries multiple different applications in the industry.
Okay, and on your booth particularly, you have a range of stuff, but I know you have some new stuff and some sort of cost-saving stuff as well.
Yeah, so we are promoting our Durafuse product line, which is Durafuse LT, low temperature, Durafuse HR, high reliability, and a flux vehicle, so very exciting, is Indium 12.9 HF.
Okay.
And along with that, as you just mentioned, there are some needs for cost-saving initiatives, so we do have a wide range of low silver alloys that we are offering as well.
Okay, so I mean, obviously the cost saving, we know how expensive silver's got. Tell me some of the benefits for your other products. You know, why you brought them out. You know, what are the trends you're seeing, and you know where they've come from, really. Sure.
So if we start with the Durafuse LT, it's low temperature in regard to SAC, so it's not your traditional tin bismuth low temp. The lowest peak temperature we typically will recommend is 205 Celsius, but still much lower than 240, which is what you typically are going to use when using SAC 305. And what this enables is specifically high performance computing. We're seeing larger and larger chips.
Yep.
These chips, they like to warp. They're not always perfectly flat as we would like, and that poses some challenges when you're trying to attach it to a circuit board.
Yeah.
So by reducing that peak temperature, we're actually able to help manage that warpage and ideally eliminate the defects that come along, or the warpage-induced defects.
Yeah, and like you say, chips and boards are getting bigger just due to the whole AI situation and the data centers, so that's something that you're going to have to overcome more and more, I guess, in the future.
Yeah, we see it especially in the data centers and AI, but not only there, and power inverters, anything where more and more power is flowing through these boards. They're getting thicker, the components are becoming more robust. And with that, there's another challenge beyond the warpage, is uneven heating.
Okay.
So when you have these densely packed boards and all different size components, in a perfect world, everything is
nice
reaching
flat,
240, and you're happy when you're using SAC. Now, it's when you have something with a lot of thermal mass, trying to get that piece up to the proper temperature, you risk damaging all these smaller mass pieces. Yeah. And Durafuse LT enables you to change your alloy. Now you're reducing that peak temperature required to wet and reflow the solder. And you can now take that largest thermal mass, which was your challenge of getting that up to temperature. You can now reflow that at 205 or 210.
Okay. And
you can still have a 30-degree delta on the board, and there's no risk of damaging those components because they're still only reaching 240, 250 max.
Okay, well that's fantastic. Yeah, that's a real good, because like you say, things are becoming more complex, and although things are bigger, they're still really jamming everything in there. So.
Yeah.
The other bits and pieces you have on your stand, your other products, again, tell us the benefits, tell us why they've been developed, and how they've sort of made the progression since the last time we spoke.
Sure. Another one, the Durafuse HR, high reliability. It's typically slightly different industries. We see it more in the automotive, industrial, or infrastructure space. But typically where SAC 305 always used to work, now with more demanding mission profiles, or they want a longer lifespan of these products, SAC is not cutting it anymore.
Okay.
And part of the reason may be the higher power going through the board. But an interesting one we've been seeing is sustainability or cost savings. Some devices which are typically left on all the time, so they're kept at 100 Celsius operating temperature. Now they're powering those down, and actually it is enabled by AI to kind of track the patterns and trends and know when they can reduce that power.
Okay.
But when you do that, now you're introducing a cyclical loading. So you have your components hot, cold, and SAC 305 just may not be able to survive that depending on the conditions. So our Durafuse HR was designed specifically for minus 40 to 125 thermal cycling. We wanted at least 3,000 cycles. That was our goal. And in a lot of the components we've tested, a lot of the different customers using it, we see it's working very well.
Okay.
But the thing that sets it apart from some of the other high rails on the market is it's a low voiding high rail.
Okay.
So typically a high rail alloy, in order to improve the strength and durability, you have to add some other elements to the standard SAC tin silver copper. Now you have these 6-7 element systems, and with that poses some new challenges, voiding being one of them. But utilizing the Durafuse technology, our dual powder technology, we're able to keep those high rail properties, but also drive down the voiding.
Okay, wow, fantastic, that's great. Well, it seems like, obviously there's been a lot of sort of different levels that you've had to deal with to get past this and get to the next stages. So there must be a lot of interest coming to the stand and lots of questions that you're getting from your customers and your potential customers. Are they understanding the processes? Are they coming to you with new challenges that you're sort of having to face again?
I would say it's these last few years, it's the increase in new challenges, and just things are changing faster than ever. So
Okay.
we're staying on our toes, and we're doing what we can to solve these complex assembly challenges because, like I said, SAC 305 just isn't cutting it anymore across the board. So you need to be a little bit more versatile, open-minded to try some of these specialty alloys to enable the assembly of these complex boards.
Yeah. Okay, fantastic. Well, we look forward to hearing what you guys are doing next. Clearly not standing still as all these challenges keep coming towards you. And I hope you have a really successful rest of the event. And we look forward to speaking to you again soon.
Thanks so much.
Thank you very much.